Welcome viewers to the 19th lecture of the online course Non-Traditional Abrasive Machining Processes like USM, EJM and AWJM. Okay. So, we have finished almost all the different items like USM and EJM has been completed, and AWJM, which means abrasive water jet machining, that we are almost on the way to completion. Sorry. So, today in this lecture we will be learning about some of the applications and equipment details of abrasive water jet machining that we have not completed in the previous lectures. We have had quite a lot of discussion about some of the equipment, the working principle, the analytical derivations, and the mathematical some numerical calculations also. And today let us tie up the loose ends, so that we will be ready for the last lecture, in which we will be extensively discussing some MCQs, because after all MCQs are the ones through which you interact with the system. So, let us move on right away with our discussion. So, these things we have roughly discussed. In case there are some points that we have left behind, we will quickly go through these points, like what is water jet machining good for? Water jet machining and abrasive water jet machining, there is a distinction, because water jet machining does not contain abrasives, but it is the velocity range of water jet is same as abrasive water jet, maybe a bit higher, because it is not decelerated by the abrasive content as in abrasive water jet machining. So, plastics, cardboard, soft materials, paper, insulation, rubber, food. So, in case of food like frozen meat, leather, etc., there is no risk of contamination due to abrasives being present. So, water jet machining is extremely suitable for these. So, paper, paint removal, cleaning, soft materials, then textile, peening, that means a sort of hardening, and carpets, some varieties of cloth, etc. So, in all these cases water jet machining is quite suitable. And what is abrasive water jet machining good for? We have already discussed some of the materials. Let us see whether there are some additions which we had not mentioned before, like glass, ceramics, composites, semiconductors, polymers, MMCs, metal matrix composites, ceramic matrix composites, titanium and titanium alloys, nickel and nickel alloys, brass, aluminum, steel. That means almost each and every metal, wood, stone, granite, rocks. This is one in which it excels over other methods like say EDM, ECM, etc. Concrete, then glass, fiber, metal laminates, turning, drilling, pocket pilling, etc. So, what kind of abrasives are used? Do we use silicon carbide, aluminum oxide? Generally not. We use garnet, which is generally a gemstone, and there can be different compositions of garnets. So, we are not putting in any specific composition here, and typically red garnets are used. Why is this garnet used? Because first of all, it is available in abundance. It can be found in mines, in sediment, in alluvial deposits, but from the mines, the ones which are available, they can be very sharp and hard, etc., and therefore, they are an obvious choice from the mines. So, if you ask me what is the reason because of which it is being chosen, because it is hard and it has sharp edges and it is available in abundance and it is relatively chemically inert. There are some alternative abrasives like olivine for aluminum, okay, and its advantage is that if you are not cutting some very hard, very tough material, say aluminum, you are cutting aluminum, in that case you can do with olivine, which is not as hard or sharp as garnet, and it will be easy on your equipment. That is, your equipment won't be worn down as much as in case of the use of garnets. Okay? And generally it's from 125 mesh size to 60 mesh size. And dry ice could be a good candidate, because dry ice disappears after use, and therefore it will be causing less environmental pollution and contamination. So, some of the data that that could prove to be useful to us, some of the points, finer points that we might have missed out. What's the pressure range? We have done so many problems with 4,000 bar. Generally, the pressure range is 2500 to 4,000 bar, give or take a few hundreds of bars. So, that generally defines the velocity range that you are going to achieve, because as we know, V square is equal to 2 p by rho. So, if pressure is fixed, and if you are considering water, then the velocity of the initial velocity of water is fixed by the pressure. So, you can immediately say this is the velocity range. Abrasive flow rate can be as low as 0.1 kgs per minute and as high as 1 kg per minute. In the numerical problems that we have solved, you might find a reference to abrasive flow rates of 0.6, 0.8, etc., and in some cases we might have crossed it. Okay. For the sake of mathematical problems to formulated on some basic principles, we might be going slightly away from it, but it does not really matter for mathematical problems. But generally, when you are working for all practical cases, generally we try to be within this particular limit. Standoff is generally 1 to 2 millimeters. Okay. If you go for higher standoff, the MRR will fall. If you go for lower standoff, the jet might not be able to come out properly. And generally, as the jet moves outwards, it will be flaring. That means its diameter will be increasing. So, some long chain polymers are generally added to the water to stop it from fragmenting and flaring, etc. Okay. So, long chain polymers called stabilizers generally might be added. Groove depth. We can handle groove depths between 1 millimeter to 250 millimeters. Of course, it must be depending upon the particular material you are cutting, and grooving or cutting speeds can be as low as 100 millimeters per minute, and you can go as high as I think it should be 5 meters per minute. Sorry. So, 100 millimeters per minute to 5 meters per minute. The focusing tube is made up of premium composite carbides. Ordinary carbides won't do. It's 0.8 to 2.4 millimeters, and so it's interesting to notice that the focusing tube, which ultimately sends the abrasive water jet into the atmosphere, its diameter is 0.8 to 2.4 millimeters, while the orifice is 0.1 to 0.4 millimeters. It is through the orifice that the water first comes out from high pressure and enters the mixing chamber. The mixing chamber is generally of the diameter of 6 millimeters to and with a length of 10 millimeters. That is also made of premium composite carbide. Mind you, the focusing tube and the mixing chamber, they are they have to withstand quite a lot of wear and tear because of the abrasives entering into the water stream. And the orifice is generally made out of some very hard, very resistant and tough material. Common choices might be jewels like sapphire, ruby, diamond, etc. And diamond gives a life of say 800 to 2000 hours, but the others do not give that amount of life. So, this is some typical data about the abrasive water jet machine. And as you can well understand, So, it's going to be quite costly from the maintenance side, because many parts are going to wear off after several hours of use and have to be replaced. How do we get rid of the abrasives? Because so much abrasive coming out with so high velocity, if it is open to the atmosphere, we will definitely have some environmental pollution and contamination problems. So, generally it might be put into water. The easiest way, have a water basin into which the abrasives will be put in, okay? And therefore, once it's trapped inside water, it cannot go out into the open atmosphere. Or there might be some submerged steel and tungsten carbide balls, and it gets trapped inside in between these and cannot escape. Or we might have catcher plates which are so angled that once these abrasives come inside, they get reflected multiple times in these catcher plates, and ultimately they cannot escape outside. Okay. So, it is a very important point to take care that the abrasives do not get exposed and get into the outer environment. Well, all the abrasive water jet machines that we have been referring to during our analysis, mathematical problems, etc., they are of a particular type called entrained abrasive jet machines, which simply means that when water is coming out through the orifice and entering the mixing chamber and ultimately going out through the focusing tube into the atmosphere, inside the mixing chamber we produce a sort of vacuum, okay, due to its sudden flare in diameter, and into this vacuum the abrasives get sucked in and they are entrained into the jet. Some air also gets entrained, but this is the way in which we are doing it. Now, obviously, this has its advantages and also its problems. Determining the amount of consumption of abrasives is very easy in this case, and the problem is that it's not possible to completely stop the entrainment of air. The more is the amount of air entrained, the less will be the efficiency of the machine. But it is possible to make a have a machine in which have some equipment in which entrainment of air can be completely avoided. So, as it is written here, the suspended type, okay, abrasive suspension jet, ASJ sometimes it is referred to. In this kind of abrasive water jet machine, we have the abrasive water slurry already created and put inside some pressure vessel. So, once again the high pressure water comes in, pressurizes this abrasive water slurry to come out and carry out machining operation. Now, there are obviously some problems with either system, and the problem with this abrasive suspension jet is that it is difficult to control the first of all difficult to monitor the consumption of abrasives in the system, and it is difficult to introduce the abrasives into a confined chamber which is under very high pressure. So, let us have a quick look at this. So, otherwise it is very good, because we can get higher accuracy, higher cutting ability, higher cutting speeds. There is absolutely no air entrainment, and therefore, it should be obviously the better choice, but due to this problem, that is introduction of abrasives into the system being a problem, it is not that popular. So, in this case what do we have? High pressure water is still used here, and we have a pressure vessel, there is an isolator, and here is the suspension of abrasives in water. and it has an outlet through which ultimately it is led to the machining zone. So, when this suspension is gradually getting depleted, it starts from here when it is full and it is gradually getting depleted. It is sometimes difficult to estimate when a replacement is required. So, generally we have a 2 vessel system. There will be in parallel yet another vessel which is full. The moment this is emptied up, we have the provision of machining, abrasives getting sucked in from the second pressure vessel, and this is removed and replaced by a fresh one. So, this way, by alternatively taking the abrasive slurry from this vessel and the second vessel, the system can be continued without any pause. Okay. But this is not as popular as the previous one that we have discussed, which is entrainment. So, before completing this course, we should definitely look at the plus points and the drawbacks of the system. Plus points. As we have discussed before, abrasive water jet machines can cut virtually any material like pre-hardened steel, mild steel, copper, etc., etc. It can cut thin material, it can cut thick material, and it can make all sorts of shapes only with one tool. There is no heat generated and it leaves a smooth finish, okay. And sometimes secondary operations might not be required at all. And it is a clean cutting process without gases, oil, dust free, okay. Debris of material, debris of the cutting process, this is minimal, it is quite safe, and last of all, it can machine stacks of thin parts all at the same time, and if some material is non-homogeneous, it will not cause a problem. It might cause a problem in other cases. It might cause a problem when, say, thermal properties of a body, they are varying drastically from one point to the other. It might cause a problem in case of laser beam machining, but any properties, even if they be different in this case, does not pose that much of a problem in case of abrasive water jet cutting. Let us look at some of the drawbacks, okay, because there must be some drawbacks. Otherwise, abrasive water jet cutting would have replaced laser beam cutting, it would have replaced wire electrical discharge machining process, it would have replaced gas cutting, where you use excess of oxygen with acetylene to burn and remove material, and it would have removed plasma cutting, it would have removed replaced hacksaw, power saw, band saw, and all sorts of slitting saws. Every cutting operation would have been replaced by water jet cutting because of its obvious advantages that we have discussed previously, but it is not so. Do you see a water jet, abrasive water jet machine in just every shop that you have visited, perhaps for your industrial training, for industrial visits, and if you are associated with some mechanical workshop, etc. Do you see abrasive water jet machine? It is extremely rare. So, there must be some drawbacks. Okay. The drawback is that a limited number of materials can be cut economically. Okay. Costs are high. Rather, we will say that for a limited number of materials, costs are low and costs are generally high. Cutting rate is greatly reduced for materials like tool steels, that means hard, tough materials, etc. Immediately you will find, yes, you can cut it, but at a very slow rate. So, this is the main problem. It can cut any material, but it does not cut them either economically or in a reasonably at a reasonably fast pace. That is one of its main drawbacks, because of which it has not got a blanket acceptance in the industry. Cutting of very thick parts with dimensional accuracy, it's it's a problem, because sometimes what happens is the cut starts moving towards one side inside the thick material. Okay, it moves to one side, so that you won't get a straight cut if it's very thick material, because we are claiming that it can cut any thickness 120 millimeters, 250 millimeters, but the cut will start moving, may shift in an angular manner, in a curvilinear manner to one side. Okay. So, taper in very thick materials is also a particular feature which is a drawback, and it is expensive, already discussed. So, as it has high maintenance requirements, generally it is not suitable for mass production, and as the jet is a material jet, it suffers from stream lag. So, we have some material moving through. What is this stream lag? Let us have a quick look. Let us say these are some of the abrasive jets which are coming in. It is cutting this material, this part has already been cut, and this is the particular pathway of these tools, I mean of these abrasives. Now, this is a problem, because when you are cutting, the operator or the machinist expects that I have cut up till this point, but this material is uncut. Now, what is that? What problem does it create? Whenever you are cutting, say a corner, say this is one part and you intend to cut like this, you will have a big problem when you are turning. So, you are cutting this way, you are moving this way, you are moving this way, etc. You are thinking that you have cut up to this corner when the when the cutter reaches like this, but actually it has left behind this particular uncut material. Maybe on the bottom it has cut only up till this point, while you have reached up till this point. That is a problem, because at this point you are going to take a turn, and immediately this part is going to remain uncut. So, the laser so the cutting jet, water jet is proceeding this way, and then say it takes a turn and it starts moving up, I mean takes a right angle turn. So, it is moving this way, and every time it takes a turn, it will be leaving behind this material uncut. So, stream lag is unavoidable, and it creates defects, geometrical defects in the workpiece, and we have to have some method by which we can remove it. Okay. So, this is listed as one of the drawbacks. A quick look at a comparative study of abrasive water jet machines and say laser beam machining. Abrasive water jet machines can machine reflective materials. This is a very strong point in support of abrasive water jet machines, while lasers do have an issue in these cases. For example, if you have a very shiny surface of say aluminum, silver, or some such material which is the surface is very polished and is having a high reflectance. For example, if you have metals and if you have a carbon dioxide laser at 10.6 microns wavelength, you will find most of it is getting reflected. How much is reflected? Say if I say more than 90%, would you be very much surprised? It can be as high as 95 to 96% also in some cases. So, even if you have a laser with kilowatts of energy, kilowatts of power, would it make any difference if half of it is reflected? So, lasers have an issue with materials which are highly reflective or rather they are polished to a level so that most of the power is getting reflected. Lasers might be rendered ineffective, but this is not the case with abrasive water jet machines. Okay? They can machine reflective materials. Materials to be cut. A material to be cut does not need to be uniform in properties. This we have already discussed. Okay? And there is no thermal distortion. This also we have discussed, because as we know, abrasive water jet machine is essentially having water in it, so that cooling is automatically achieved. In laser beam machining, in electron beam machining, in electrical discharge machining, okay, in all these cases, heating up is definitely one of the issues which has to be addressed, because heating will cause thermal changes and associated property changes, and therefore, material properties will also start varying. And in abrasive water jet machining, since we are using very simple system with mechanical components, the safety is definitely higher. Now, a look at say abrasive water jet machines and electrical discharge machinings. Water jets can act faster. In what way? Suppose you are cutting and you are using abrasive water jet machines and you are using wire electrical discharge machines. What's the problem with wire cut electrical discharge machines? The problem is essentially you have to carry the current. Okay? Essentially you have to carry the current through the the wire, and the wire, as we know, is going to have a diameter how much? 250 microns, and 250 microns thickness wire can hardly carry the current that you would have liked it to carry, and therefore, cutting speeds are generally restricted by this. But with an abrasive water jet cutter, you can well reach speeds of 5 meters per minute. Okay, that is considerably higher than what you can reach with wire electrical discharge machines. So, you might say, I will supply as much current as would be required for that sort of speeds, but you are restricted by the wire. So, wire will be having a maximum capacity to carry current, and that restricts it. Abrasive water jet machines are not restricted by any a requirement of electrical conductivity of the material, and therefore, virtually any material can be cut. And uniformity, once again these points they are already known to us. Initial hole is made by abrasive water jet machines itself, while initial hole might have to be made in case of cutting methods in electrical discharge wire electrical discharge machining. No thermal damage, and setup is also minimum. To end it, just like I am giving you take home problems, take home assignment. This is one take home assignment, and if you want you can answer it. If you do not want, you need not answer it. Okay? So, it is just for those students who feel interested to proceed a bit more. So, this has a, as I said, this has all take home assignments are going to have different flavor, not the run of the mill problems. So, what do we have here? You have to write made in India inside a metallic tube by grooving, and these grooves have to have constant depth, and you select abrasive water jet machine for the purpose. The velocity of grooving is obtained by the computer controlled uniform circular motion of the tube, whose diameter is 30 millimeters, and uniform linear motion of the abrasive water jet nozzle as shown. So, let us see what is shown. This is it. This is the tube, this is the end, and inside you are going to write made in India. So, if you want to write made in India, this is your nozzle, which has a squarely bent neck. This is the jet coming out. So, the motions which are provided here to write all the letters is straight line axial motion of the abrasive water jet machine nozzle, and circular motion of this tube. What's the diameter of this tube? 30 millimeters. Okay. What's the speed of this particular nozzle? 30 millimeters per minute. And what is the rotational speed? It's a constant rotational speed, either on or off. That's let's read it up. Yes, the velocity of grooving is obtained by the computer controlled uniform circular motion of the tube whose diameter is 30 millimeters and uniform linear motion of the abrasive water jet nozzle as shown. What's that uniform linear motion? Is 30 meters per minute, mentioned later. Cutting of the letter D is done by other means, because it has circular interpolation and that's going to cause problems, and we should not bother ourselves with the writing of D. But for the cutting of the vertical line of the letter E, okay, the vertical line of the letter E, only the linear motion 30 meters per minute is used, and for cutting the horizontal arms of E, only the circular motion equal to RPM 1000 by pi is used. If the mass flow rate of the abrasives is 1 kg per minute for cutting E, how much would you have to change the mass flow rate of abrasives while cutting the inclined line of the letter N at 45 degrees to horizontal, so that it is cut with the same groove depth? The linear and circular motions simultaneously take place during this cut, and mass flow rate of water is 3.79 kgs per minute. Let's see. So, now this makes more sense. This is going to move this way 30 meters per minute. This has 30 millimeters diameter, and this rotates at 1000 by pi RPM. And in case of the writing of this inclined line of N, both these motions will be taking place together, and at that time obviously the speed of cutting, speed of grooving will be increasing, because these two things have to take place simultaneously. So, if speed of grooving increases, in that case, if the abrasive flow rate is kept constant, you will have a problem, because in that case the groove depth will reduce. So, in that case, what should be the increase in abrasive flow rate, so that this groove depth will be maintained in this case? Okay. So, try to solve the problem yourselves. I will disclose the correct answer after the last date of submission of this assignment. This assignment is not compulsory. Okay. One last word. Do we face this problem in ordinary abrasive water jet cutting? Generally not. Generally, in abrasive water jet cutting, if it is a simple cutting of a profile, we will always try to keep the abrasive flow rate same and the cutting speed same, so that the cutting characteristics, if you are grooving, the groove depth, if you are cutting, in every case everything is uniform. Okay. So, this is just a special case to hone your mathematical skills in this particular problem solving exercise. Oh, so the solution is here. So, now we come to the end of the 19th lecture. I will meet you for the last time in the 20th lecture to end up our course. Thank you very much.